Good morning, students. Welcome to my YouTube channel. Today we will start a new chapter, that is force and laws of motion. This is the new chapter and the first session of this chapter. So in this chapter we will discuss mainly about force and motion. Force and motion, this is number one. Number two, different kind of force and their examples. Different kind of force and their example. Then very important, Newton's laws of motion. All total there are 3 laws given by Newton, so all these laws will be discussed. Next, inertia, concept of inertia of a body. Next, momentum of body. Next, acceleration, what is acceleration, concept of acceleration, which is related to force obviously. Next, elementary laws or elementary idea of momentum. When two bodies collide together, then there is loss of energy or exchange of energy, so that concept will also be covered. So elementary idea of conservation of momentum. So this chapter is basically classified into these topics, and all these topics will be discussed in 2 sessions. This is the first session. In this session 2 or 3 topics, mostly this topic will be discussed, and in the next session the remaining topics will be covered, followed by some important questions related to this chapter. Clear? So let's begin the first exercise or first session. So at first we should know what is force. Now force is something that causes pull or push on a body. It is something that causes pull or push or even sometimes hit also on a body is called force. That means it is an action. So that means force is an action which causes push, pull or hit, which causes an action which causes push, pull or hit on a body. And force is an action which causes push, pull or hit on a body. That is force. Now this force, it cannot be seen. But it can only be judged only by the effect which it produces in various body around us. It cannot be seen. We cannot see force. The thing we see is only the effects of force which it produces in various bodies around us. Clear? So that is force. And now what are its effects? Now as force, we cannot see force with our eyes. We can see only its effects on various bodies. So what are its effects? When you apply force on a body, what effects do you observe? So number one effect is that it can move a stationary body. A force can move a stationary body. Stationary body means a fixed body, the body which is fixed, that is stationary. So when we apply force on a fixed body or stationary body, it moves. That means a force can move a stationary body. That is the number one effect. A force can move a stationary body. That is number one effect. Number two effect is that a force can also stop a moving body. Suppose a body is moving and you are applying force. So what will the force will do? The force will stop the body. That means it will also stop a moving body. That means a force can also stop a moving body. That is number 2 effect. Number 3 Number 3 effects. Number 3 effect is that a force can change the direction and speed of a moving body. It can also change the direction, and also it can also change the speed of the moving body, because force is something that it is an action. That means it is a push or pull or hit on a body. So it can also change the direction of the body and also the speed of a moving body. That means a force can change the direction. A force can change the direction and speed. A force can change the direction and speed of a moving body. A force can change the direction and speed of a moving body. That is number 3. Number 4 effect is that a force can also change the shape or size of the body. Suppose you have a spring and you are applying force from both sides on the spring. So the spring will squeeze, and if you extend the spring, that means if you are applying force, if you are going to extend the length of the spring, so the spring will increase in length. That means the shape of the spring or size of the spring will change if you are applying force. Clear? So a force also can change the shape and size of a body. A force can change the shape or size of the body. A force can change the shape or size of the body. So these are the effects of force. The definition of force, what is actually a force, and its effects. Next we will discuss the classification of force. How forces are classified. Classification of force. What is classification of force? Now, force are actually classified into 2 types. One is balanced force and one is unbalanced force. So there are 2 type forces. One is balanced force, and number 2 is unbalanced force. One is balanced force and one is unbalanced force. Now, what is balanced force? Now, suppose there is a body. Let me draw a diagram so that you can properly understand what is balanced force. Suppose there is a body. There is a body on a floor. Clear? There is a body. It is a body on a floor. Suppose this is a block. This is a wooden block. Body, that is, suppose it is a wooden block. It is fixed on a floor, and here is 2 strings are attached here. 2 strings are attached. One is string. This one is string. One string, that is string A. It is string A, and it is string B. Clear? So 2 strings are attached, and it is a surface. This one is a horizontal surface or horizontal floor. Horizontal surface. Clear? Now, suppose one of your friend is stretching the wooden block from this side, and the second friend of yours is stretching this block from this side. That means these 2 forces are opposite. Clear? Then this wooden block will remain fixed. This wooden block will not move. One of your friend stretching this wooden block from this side, that is by string A, and the second friend are stretching this wooden block from this side, that is by string B, with equal amount of force. Then this wooden block will remain fixed in this position. This wooden block will not move. Then this force will be termed as balanced force. That means here more than one force is applied on a body. More than one force. It can be 2 forces, it can be 3 forces, it can be 4 forces, but more than one forces. That means when the net effect produced by the number of forces acting on this body is 0, then the forces are said to be balanced forces, because when both this force, that is string A and string B, when both this force applied on the single wooden block, then the net force of these two will be 0, because one of your friend stretching this wooden block by string A with equal amount of force to that friend who is stretching this block by string B. That means both these forces will be equal. When both these forces will be equal acting on this body, then the net effect on this body, net effect of force on this body will be 0. In that case, the wooden block will not move. The wooden block will be remain fixed in its position. Then we say that these two forces are balanced force, because these two forces balance this wooden block so that the wooden block will not move. It will be fixed on its side. That is the balanced force. So the definition is, just write, when the net effect produced by a number of forces, so write, when the net effect produced by a number of forces acting on a body is 0, then the forces are said to be balanced forces. When the net effect produced by a number of forces acting on a body is 0, then the forces are said to be balanced forces. Now this balanced force, it can only change the shape of the body. It can only change the shape of the body. So the effect of balanced force is that it can only change the shape of the body. It cannot move the body. It cannot move the body because the forces are balanced. So there is no single force that will act on a body. The net effect will be 0. That means the body or the wooden block will not move. Only the shape will be changed. That is the effect of this balanced force. So only effect is size or shape will be changed. Size or shape will change. Its size or shape will change. That is the only effect of balanced force we have got. Only the shape or size will be changed. Clear? So this is what is balanced force. Its practical example. What is its practical example? Its practical example is that you have seen the practical example in a tug of war. The example is that in a tug of war. So in a tug of war, what happens? The happen is that both the teams apply similar force. In a tug of war, both the teams will apply the similar force from both sides. When both of the teams apply similar force from both the sides, the rope will not move. The rope will not move, and thus the resultant force will be 0, and then the force will be termed as balanced force. In a game of tug of war, what happens is that there is a rope. Suppose there is an object and there is a rope, and here is also a rope. So here suppose they are a team A, this is team A, and there is team B. So when both these teams apply similar force or same force from both the side, the rope will not move. That means this object, suppose an object is tied with this rope, there is a rope and object is tied with this rope, this object will not move. When both the teams will apply similar force, the object will not move on either side. It will be fixed in its side. Then this force will be termed as balanced force, because the force acting on this rope or the force acting on this body will be the 0, because here the force applied by team B will cancel the force applied by team A, because both the force will similar. That means both these forces will be cancelled by each other. That means the net force acting on this body will be 0. So the body will not move, it will be fixed on its side. That is the balanced force. Clear? This is a practical example of balanced force. Next, second one is your unbalanced force. Second one is your unbalanced force. Now in case of unbalanced force, the net effect produced by the number of forces will not be 0. Here the net effect acting on a body, the net effect acting on the body is 0. But in case of unbalanced force, the net effect acting on the body will not be 0. In that case, the force will be termed as balanced force, unbalanced force. Suppose, a practical example is that, suppose there is a wooden block, there is a big wooden block, or suppose consider it as a refrigerator. Consider it as a refrigerator. Clear? So this is the refrigerator, and you are moving this refrigerator alone from this side. That means you are applying force from this side. Clear? So in this case, the refrigerator, if you push the refrigerator with small force, if you push this refrigerator with small force, the refrigerator does not move, because due to the frictional force, acting in a direction opposite to the force. This refrigerator is, suppose it is on a floor, so between the refrigerator, between the bottom of the refrigerator and the floor, a force is operate, that is we know as frictional force. So what is frictional force? A force is in between the block of the refrigerator, or the bottom of the refrigerator and the floor. It is acting between the bottom of the refrigerator and the floor. That force is termed as frictional force. So whenever you are applying small force on the refrigerator does not move due to this frictional force. This frictional force is opposed. This frictional force will oppose your forces. So the refrigerator will not move if you apply small force. But if you push the refrigerator harder, then this pushing force, that means the force applied by you, will be greater than the frictional force. Only in that case the refrigerator will move. Clear? That means here in refrigerator the two forces are acting. One is the force applied by you, and the second one is the frictional force. When both these forces, if both these forces are same, then the refrigerator will not move. That means in that case the force will be balanced force. But in this case the two forces will not be similar. That means the net effect acting on this refrigerator or acting on this body will not be zero. That's why the force is termed here as unbalanced force. When you are applying small force, you are trying to push the refrigerator with a small amount of force, you cannot move this refrigerator, because the frictional force acting between the bottom of the refrigerator and the horizontal plane or horizontal surface will oppose your force. In that case you cannot move this refrigerator. But if you push this refrigerator harder, then the force given by you will exceed the frictional force. Only in that case the refrigerator will start moving, and in that case the force will be termed as unbalanced force, because here the net effect of two forces acting on this refrigerator is not zero. That's why it is unbalanced force. Clear? So here in case of balanced forces the net effect is zero, and in case of unbalanced forces the net effect is not zero. Clear? So that is unbalanced force. So what is its effect? The effect of unbalanced force. The effect of unbalanced force is that this force can cause the movement of body. That means this force can move a stationary body. So its effect will be, it can move a stationary body. That is the effect of unbalanced force. Clear? Now practical example. What is the practical example? The same example, that is in a tug of war. The same example I will be sharing with you, the same example, but only the difference is that here between team A and team B, one of the team will apply greater force. In case of balanced forces, both team A and team B will apply the similar force, the same force, that is the balanced force. But in case of unbalanced force, suppose team A is applying a greater amount of force. So what will happen? The rope or the object tied with the rope will move to this side, that means towards A. In that case the force will be unbalanced force, because the net effect on this body or on this rope in that case will not be zero. Similarly, if team B is applying the greater amount of force than team A, the object or the rope will move towards B. Clear? In that case also the net effect on this body will not be zero. That means team B will applying greater amount of force. That's why the object is moving towards B. So in that case, if one of the team is applying greater amount of force, then the two forces will be unbalanced force. That means the net effect of force on a body will not be zero, and the object will start moving towards the team that will apply greater amount of force. So that is balanced force and unbalanced force. Clear? Next, Next, that is next topic is Newton's laws of motion. Newton's laws of motion. Newton's laws of motion. That is very important. Newton's laws of motion. Now, Newton, he is a scientist. Newton studied the idea of this motion of an object. He has actually studied the idea of the movement of this object, how object is moving when force is applied. So he formulated three fundamental laws. He actually formulated three fundamental laws that govern the motion of the object. So if you apply force on a body, or if you apply force on an object, there is a motion in that object. The effect is that the object will move if the force is unbalanced force, and if the force is balanced force, the object will be fixed, only its shape or size will be changed. So when motion produced, if we are applying force, then only motion is produced. So Newton studied three fundamental laws which govern this motion of object, which actually govern this motion of the object. So the three laws are known as these Newton's laws of motion. The laws governed by Newton, or the laws given by Newton actually governs the laws of motion. So that three laws given by Newton is termed as Newton's laws of motion. So there are three laws: first law, second law, and third law. But in this session we will discuss only about the first law, that is Newton's first law of motion. So make a heading: Newton's first law of motion. Newton's first law of motion. Newton's first law of motion. So the statement is that it states that an object will continue to remain in its state of rest or uniform motion along a straight line unless an external force acts on it. That means an object will remain stationary if no force is applied. An object will be moving if no force is applied. Clear? So statement is that an object will continue to remain in its state of rest or uniform motion along a straight line unless some external force acts on it. If you are not applying any external force, the object will be fixed. If it is fixed initially, and if it is moving with a uniform acceleration, it will continue to do so if you are not applying any external force on it. That is the statement given by Newton, and it is the first law. So it means that all objects resist change in their state. Every individual object will resist in their state. That means when you are applying force on an object, all objects will resist change in their state. That is the statement given by Newton, and it is termed as Newton's first law. So first law is that it states that I write the statement. It states that an object will continue to remain in its state of rest or it states that an object will continue to remain in its state of rest or of uniform motion along a straight line path unless an external force acts on it. This is the statement given by Newton. This means all objects resist resist, all objects resist change in their state, change in their state, all objects resist change in their state. That is the Newton's first law of motion. That is the statement given by Newton. So it states that an object will continue to remain in its state of rest or of uniform motion along a straight line path unless an external force acts on it. This means all objects resist in their state, resist change in their state. That is the statement given by Newton, and it is the termed as first law of motion. So when question will be asked that write the Newton's first law of motion, just write this statement. Clear? Next example, practical example of Newton's first law of motion. What is the practical example of Newton's first law of motion? What is the practical example? So there is two practical example that is from Newton's first law of motion. One is that when a person standing in a bus, he falls backward when the bus is started moving suddenly. When the bus initially it is at rest, when it is started moving suddenly, a person standing in a bus, he will falls backward. Why does this happen? This happens because the person and the bus both are in rest. The person and the bus initially both of them are in rest while the person is standing on the bus. Now if the bus is started moving suddenly, he will falls backward because the legs of the person moves along with the bus, because the legs are attached with the bus, and the upper portion of the body is not attached. The legs of the person is attached with the bus, that is the floor of the bus, and the upper portion of the body is not attached. So initially when the bus is at rest, the person standing comfortably in the bus, but when the bus started moving suddenly, the legs will also start moving with the bus because legs are attached with the floor of the bus, but the upper portion that is not attached with the bus, so it will try to stop the lower portion, that is it will try to stop the leg. So the effect is that he will fall backward when the bus started moving suddenly. Clear? That is the first example. Second example is the reverse. Reverse is that suppose the person standing in a moving bus, the bus is moving and you are standing in a bus, and if the bus stops suddenly, you will fall forward. Because the legs are also moving with the bus, because legs are attached with the floor of the bus. So if the bus is moving, the legs are also moving. That is the lower portion of your body, but the upper portion that is also moving with the leg. But when the bus will stop suddenly, the legs will also stop with the bus because the legs are attached with the bus, but the upper portion is still continue to move. That means there is a change of motion in your body between the upper portion and lower portion, so you will fall forward. So the question can come in your exam, that is when the bus suddenly stops, what is the effect? When the bus suddenly starts moving, what is the effect? And these two effects is the example of, or practical example of, Newton's laws of motion. Clear? Next concept is inertia. It is also the concept also derived from Newton's first law of motion. The concept inertia is also derived from Newton's first law of motion. That is, next concept is inertia. It is also derived from Newton's first law of motion. This inertia concept is also derived from Newton's first law of motion. Now what is inertia? Inertia is actually the unwillingness or inability of an object to change the state of rest or uniform motion along a straight line. Suppose you are giving force on a body. That body can be stationary body, that body can be a moving body. You are applying force on that body. So initially the body will resist your force. That means it will not initially change its motion or change its shape or size. That is the effect. Initially it will not change its shape or size. That means the inability or unwillingness of an object to change its shape or size. When you are applying force on a body, the body will tend to resist your force. As much as the body can. initially it will not try to change its shape, or it will not move. It will resist your force. But if your force is greater than the resist, or than the resistive body, the effect will be that the shape of the body will change, or the motion, the body will start moving, or the body a moving body will be stationary. That is the effect. But initially the body will try to resist your force. That means it will not it is his inability, or in the body is unwilling to change its shape. So that unwillingness or inability of the body to change its shape or change its motion, that is termed as inertia. So basically inertia is the unwillingness of the body, unwillingness or inability of an object to change its state of rest or uniform motion. That is called the inertia of the object. So it is actually, inertia is the unwillingness, or you can say inability, the unwillingness, or you can say inability of an object, the unwillingness or inability of an object to change its, the unwillingness or inability of an object to change its state of rest, to change its state of rest, the inability or unwillingness of an object to change its state of rest or uniform motion along a straight line. The motion will be obviously along a straight line, that is termed as inertia. It is called inertia of an object, inertia of an object. Clear? So the definition is the unwillingness or inability of an object to change its state of rest or uniform motion along a straight line is called inertia of an object. Now this inertia is a property. It is present in every object or every body. That means every body will try to resist the change in their state. That is, if the body is moving, it will continue to move, and if the body is state, it will remain in its state. That is the Newton's first law. That the statement is given by Newton's first law. And the property, that is the unwillingness or inability, that property is termed as inertia. And this property is the inherent property. This property is the inherent property of a body. That means it is present in all the objects or all the body. This Newton's first law, that's why Newton's first law, it is sometimes known as Galileo's laws of inertia. This Newton's first law of motion, that's why sometimes termed as Galileo's law of inertia, because this inertia property is actually derived from Newton's first law of motion. That's why this Newton's first law of motion is often termed as Galileo's law of inertia. So it is also, this law is also known as Galileo's law of inertia. This first law of motion, Newton's first law of motion, that's why known also as Galileo's law of inertia. Now this inertia is actually measured by mass. And the relation between inertia's mass, that is inertia, if it is represented by I, suppose inertia is represented by I and mass is represented by small m, so I will be directly proportional to small m. The inertia will be directly proportional to small m. That means if mass is increased, inertia will also increase. If mass is decreased, inertia will also decrease. That means a heavy body or heavy object will have more inertia than the lighter one. A heavy object or heavy body will have a higher inertia or greater inertia than the lighter one. Suppose we have two bodies. One of the body mass is 2 kg and the another body having mass is 5 kg. Now 5 kg body will have greater inertia because here mass is higher. 5 kg body, the mass is higher, mass here 5 kg and mass here is 2 kg. So inertia is directly proportional to mass. So higher the mass, higher will be the inertia, lower the mass, lower will be the inertia. That means the body having mass 5 kg will have greater inertia than that of body having mass 2 kg. Clear? Next types of inertia. What are the types of inertia? or we can say classification of inertia. Now inertia, there are three types of inertia. It is divided into three types. Inertia, it is divided into three types. It is divided into three types. One is inertia of rest. Inertia of rest. One is inertia of rest. Second one will be inertia of motion. Second one is inertia of motion. Second one is inertia of motion. And the third one is inertia of direction. Inertia of direction. So there are three kinds of inertia. One is inertia of rest, inertia of motion, and last one inertia of direction. Clear? Now what is inertia of motion? Inertia of rest. First we will discuss inertia of rest, then we will inertia of motion, then inertia of direction. So first one, inertia of rest. So what is inertia of rest? The tendency of a body to oppose any change. The tendency of a body to oppose any change in its state of rest is called inertia of rest. Now the threes are actually inertia. That means the body initially is unwilling, or the body will not try to change its shape. It will not try to change its direction. It will not try to change its motion. Clear? On that basis, the inertia is classified into three types. There is inertia of rest, inertia of motion, and inertia of direction. So when inertia of rest, it is when you are applying force on a body and the body is trying to resist your force by it will not change its state of rest. If initially the body was moving, it will continue to move, and if the body initially is at rest, it will be on its position. That means it will be continue to be in its rest form or state form. That is called inertia of rest. So the statement will be, or the definition is, that the tendency of a body to oppose any change, the tendency of a body to oppose any change in its state of rest is known as inertia of rest. So write the definition: the tendency of a body to oppose any change in its state of rest is known as inertia of rest. Clear? What is the example? Example is the inertia of rest. The example is when suppose a bus suddenly starts moving forward. The same example I am giving you. When a bus suddenly starts moving forward, then the passengers in the bus fall backward. Suppose a bus, if suddenly starts moving forward, the passengers in the bus will fall backward, because when the bus was moving, when the bus was suddenly moving, that means the bus initially is at rest. The bus initially is at rest, and when the bus is initially at rest, the passengers also in their rest position. Now if the bus suddenly starts moving, the passengers will also starts moving with the bus, because passengers are inside the bus. So if the bus is suddenly starts moving, the passengers will also starts moving and they will fall forward. Clear? Because the state of bus initially is at rest, and in that situation the passengers are also at rest position. But now if the bus suddenly changes its state, that means if the bus is suddenly starts moving, the passengers will also change their state. That means they will also start moving. But in that case, if it is happens suddenly, the passengers will fall forward. Clear? That is the example of inertia of rest. So that is inertia of rest. Next one, inertia of motion. So what is inertia of motion? The tendency of a body to oppose any change in its state of uniform motion. Here it will oppose its state of rest. The body will oppose its state of rest, and in case of inertia of motion, it will oppose its state of motion. That is the inertia of motion. So the definition is the tendency of a body to oppose any change in its state of uniform motion. The tendency of a body to oppose any change in its state of uniform motion is known as inertia of motion. So write the definition: the tendency of a body to oppose any change in its state of motion, or more precisely state of uniform motion, is known as inertia of motion. Clear? The same example. What is the example? The passengers fall forward when a fast moving bus stops suddenly. Suppose a bus is moving and it stops suddenly. The bus is moving and it stops suddenly. The passengers will fall forward. Initially the bus is moving and it stops suddenly. So the passengers in the bus will also stop suddenly, and in the effect is that they will fall forward. That is the inertia of motion. Next, last, that is inertia of direction. So here the body will change the body will try to resist its direction. That means the body will oppose its direction. That will be the inertia of direction. That means the statement will be the tendency of a body to oppose any change in its direction. The tendency of a body to oppose any change in its direction of motion is known as inertia of direction. So write the definition. The tendency of a body to oppose any change in its direction of motion is known as inertia of direction. Clear? So what is the example? Example will be, suppose a stone, you are tied a stone with a thread. You have tied a stone with a thread. So a stone tied to a thread, suppose you are moving this in a horizontal circle. You have tied a stone with a thread and you are moving that stone in a horizontal circle. So suppose the thread breaks while you are moving horizontally, suddenly the string or thread breaks, the stone flies away tangentially. The stone you are tied, that will flies away tangentially. So that direction is known as inertia of direction, because when you have tied a stone with a rope or a thread and you are moving that stone horizontally, the direction was somewhat different. But in case when suddenly the thread or rope or suppose you have tied something, it breaks, the stone will not continue to move horizontally. The throw will flies away tangentially. That means its direction will change. Initially that stone was moving horizontally, and when the string or rope or thread it breaks, it will change into tangentially. That means direction will change. So suppose there is a string or rope and there is a stone. So you are tied the stone with a string and you are just making a horizontal movement. That means the initially the movement of the stone will be here. If you are moving this stone horizontally, so initially the movement of the stone will be like this. Now if the string breaks suddenly, the stone will move tangentially. That means the movement will be like this. It will movement tangentially. So its movement will change. That is inertia of direction. So next concept is, so this is inertia, this is what about inertia, this classification, and next concept is momentum. Last concept in this exercise, in this worksheet, momentum. Now what is momentum? Momentum, it is also a tendency. Like inertia was actually a tendency of a particle or object, and momentum is a tendency that is also derived from Newton's first law of motion. This also momentum concept also derived from the Newton's first law of motion. So it is also a tendency. So like inertia, momentum is also a tendency. So momentum is actually the product of mass and velocity. It is actually the product of mass and velocity of the body. Suppose a mass is defined by small m and velocity is defined by v. So product means mass into velocity, that is m into v, that means mv. So mv is the momentum. Suppose momentum is defined as small p, that means momentum p will be equals to mv. That means product of mass and velocity. The product of mass and velocity is the momentum. So the definition is, it is defined as the product of mass and velocity of the body. Clear? And momentum, it is actually the quantity of motion. This momentum is actually the quantity of motion possessed by any body. Quantity of motion possessed by any body. It is defined as the product of mass and velocity. If m is the mass of body and v is the velocity of the body, then m into v, that is mv, is the momentum. It is defined as p equals to mv if p is the momentum. Clear? Now this momentum has a definite direction. That means it is a vector quantity. It is a vector quantity. As it has a definite direction, that means it is a vector quantity. Now you have know what is scalar quantity, what is vector quantity. In lower class you have studied that the quantity is two types. One is scalar quantity and one is vector quantity. Vector quantity are those quantity having their fixed direction as well as magnitude, that is vector quantity, and the scalar quantity are those quantity having only value, that means magnitude. They have no direction. That one is your scalar quantity. But momentum, it has direction as well as value. That means vector will be a momentum will be a vector quantity. Now why momentum is a vector quantity? That means momentum has a direction. Why momentum is a vector quantity? Because momentum has a direction, and momentum means mass into velocity. Now this velocity has a direction. That means as v is the part of momentum, the velocity is the part of momentum. That means momentum will also have a direction, and that's why momentum is a vector quantity. Clear? Now P equals to, we have learned that P equal to mv. So suppose example is that, suppose there is a car and its mass is suppose 1000 kg. There is a car and its mass is suppose 1000 kg, and it is moving with a velocity 72 km per hour. Suppose question is given that you have a car and its mass is 1000 kg. That means small m given 1000 kg, and it is moving with a velocity 72 km per hour. That means velocity is also given 72 km per hour. We have to find out the momentum. That means we have to calculate the P. So the formula is P equals to mv. So just write P equals to mv. The value of m given as 1000 and velocity is given as 72 km per hour, but it is given as 72 as km per hour, but we have to convert this into meter per second, because velocity is always calculated in meter per second, and mass is always calculated in kg. Mass is always calculated here as kg, and the velocity always will be calculated as meter per second. So before putting this 72 value, we have to convert this kilometer per hour into meter per second. Only then we can plot this value. So if you convert this, this is meter per second, so kilometer means 1 kilometer means 1000 meter, and 1 hour means 3600 second. So it will be meter per second. Now reduce. So 3600, 36 2s are 72. Just reduce. So it is 20. So 20 meter per second. That means 70 km per hour means 20 meters per second. Now plot this value. That means m is 1000 kg and it is 20 meter per second. So momentum unit is kg meter per second. Now 1000 is kg and 20 is meter per second. So unit is kg meter per second. So 1000 into 20, your answer will be 2, 1, 2, 3, 4. 20,000 kg meter per second. 20,000 kg meter per second. That means the momentum is 20,000 kg meter per second. Your answer is 20,000 kg meter per second. That is the answer. So like this small numerical questions can be given, can be asked in your exam related to this momentum formula. So P equal to mv, that is P is momentum, mass is m is mass, and v is velocity. M is in kg unit and v will be velocity, that is meter per second unit. That means unit of momentum, it is kg meter per second. That is the unit. It is the unit of momentum. So unit of momentum, that is kg meter per second. Clear? So that's all. The three topics we have discussed: the force, the different kinds of force, motion, inertia, Newton's first law, and momentum. The remaining topics, that is the two laws, Newton's second law of motion, Newton's third law of motion, two also laws are there given by Newton, and also conservation of momentum, impulse, that concept also will be discussed in the next session. Clear? So that's all. Thank you.